Alright, day 1046 off the grid. Back from Castlepoint and all that, caught up with some stuff. Finally got a chance to do some, well, I would say solar stuff, but this isn't really solar, it's still off the grid, it's still alternative energy, but this is mainly wind. This is my wind control board, and as you can see, I've had a chance to make some headway into it. In fact, it's pretty much ready to install, so let's just see what we have here. We have two circuit breakers gang together, so when one's on, the other one's off. This one here is the main circuit breaker for the charge current. This one here is an electric brake for the windmill, so it basically shorts out the power source from the windmill when you disconnect, so that it's always got a load on it. If you're not familiar with wind turbines, it's a common thing you do. My wind turbine though has some intelligent smarts in it supposedly, so if you do open circuit it in a wind, it will attempt to brake itself using its own control circuitry, but it recommends not relying on that. It's not good for it. But anyway, so you don't want to operate these two together or you'll end up short circuiting your batteries, so therefore you can't. The only position you can have is on the battery and the brake off or braked. Now if it popped though, you could have this third position where they're both off, which is not ideal, but probably not likely to happen in the setup I have, because I don't expect to see 20 amps much from the wind. But just in case, we've got this nice big shunt here. This was a cheap shunt I bought for sort of clearance price from Jaycar. It was cheap for a reason. It didn't come with any, well, it didn't come with a meter, but it didn't come with any mounting hardware, so I had to come up with my own. It's also 100 millivolts at 100 amps, which is a bit odd because most shunts now would be 50 millivolts for the maximum drive current, but that matters little to me because I'm not using it with a common meter. I'm using it with an old meter that I found, and one that I specifically selected to be a pretty good match for this shunt. It reads up to 2 milliamps, that's its native reading. There may be an internal shunt in there, but I'm not going to futz with that. However, I'm shunting it to read 40 amps full deflection. I expect the useful range will be between 0 and the centre, but 40 amps just in case. Makes easy sense of the numbers then, you just times it by 20, you know. Now, this here is actually a little resistor chain. I wouldn't say network because it's only series resistors, there's two. Together they make 6.6 ohms. So this is in series with the meter, so it's a little multiplier. Because after all, once you shunt a voltage here, well, shunt a current here, you end up with a voltage. And so what this is really doing in a way is measuring volts. But a voltmeter is really just measuring amps across its own internal resistance, but you know, it's complicated, but you can still use a multiplier with an amp meter after the shunt to tweak its range. Obviously you don't have to tweak it exactly with the shunt, you can multiply it. This has an advantage of then separating the movement from the shunt a little bit and makes it a little bit more responsive, although at 6.6 ohms I don't know if that'll make a noticeable difference, but there you go. That's my shunt. So I've done it with this plug and socket arrangement because that way if I feel that my calibration is not that good in future times, because I'm only calibrating it on quite a low current, I can change this resistor very, very easily. But why don't we see it go? Put this in. It'll soon settle down to 3.6 amps and it's nearly 3.7, and as you can see on the scale it's showing that current fairly accurately. As accurate as I really need, because this is just a guide to the performance of your windmill more than anything. So that's pretty cool. I guess most of the work today was consumed in getting that shunt wired up and stuff like that. So the positive side of the meter, of course, is connected underneath to this socket here, but the negative disappears through this bracket, and that's how it's connected. That's why it looks like we're doing it magically with one wire. Pull them off now. Take a peek underneath. It's kind of grotty, but there we go. So there we are. So that bolt comes through bringing the negative, and they just go through these boards here to help mount it better, and that's just soldered to that socket there. The reason why I use such heavy cable for the negative return, well, it's desirable to use fairly heavy cable. I mean, you don't want any voltage drop between the shunt and the meter, I mean, because it's small voltages to begin with, but this is definitely overkill. The reason is because I had these blue type crimp terminals here, and they use a quite thick cable, so the best way to guarantee a sturdy, reliable crimp connection, because I did crimp them, I didn't solder them, is to use a fairly heavy cable into them rather than trying to double up and crimp a thin cable. So it was better just to use a heavy cable. Got room for it, no harm done, got plenty of it, so there we go. The meter is held in by its terminals. That was quite common in a lot of those old meters. One like this makes it real easy. This meter's kind of cool because it's kind of like a mini version of those big ones that you see on distribution boards and stuff, old equipment generators and stuff. So it's a surface mount meter rather than being what's the word, countersunk, flush mount. There we go. But of course, meters and shunts aren't the only thing I did here today. I also did some wiring, so obviously that's self-evident. This is the wire that takes the connection back to the windmill when it's short-circuited. This here will be where the negative of the windmill comes in, and that'll be where the negative goes off to the common ground on the battery bank. It's actually a terminal on the solar power regulator board, but that's beside the point. Now this fuse block I bought from Jaycar on clearance years ago, and I've been waiting for a use for it, and one's finally come up. I didn't have any fuses for it, so while I went and visited Electric Blue down in Masterton, the Jaycar stockist that we always make a point of visiting on the way out to Castlepoint, it's kind of a special little thing. Always buy some stuff from there as a kind of souvenir, so whenever I look at it or use it or whatever, oh yeah, I remember that, it was on the way out to Castlepoint, kind of thing. But I needed some wafer fuses, so I thought what better than to buy some wafer fuses from Electric Blue. Shout out to Andrew. G'day Andrew. I know he doesn't like cameras, I did film him when we went in there. Anyway, this one's 150 amps, this one's 100. Now really, I'm just using this as a really fancy combiner. I mean, I could have just done it with a couple of terminals or something, because these fuse ratings in this circuit are really just last resort fuses. They are a bit high for being effective. I mean, there's already a 20 amp breaker on here, and this is a DC rated breaker. I'll point that out again, so this will pop on DC without any problems. Not that an AC one wouldn't at 24 volts, but that's another story. So they're basically last resort fuses for now. I was umming and ahhing about what to actually task them as, and one idea was to feed the solar and wind both into one side, because these terminals are real chunky. You could easily feed another wire, 8 gauge like that, straight in there and just put them both through the one. Then I could use this side to go off to the 24 volt inverter, the Xantrix. In that case, I'd probably put the 150 amp on this side. I think that's why I bought the 150 with that in mind, in case I wanted to do that. And then this would go to the battery. I'm not going to do that right now, because the wire that goes to the battery at the moment, although it's pretty thick, I don't really think it's the best for the Xantrix, so I'll just leave its existing connection. So we'll just simply have wind through this one and solar through that one. There's space on the board here. That's deliberate. Didn't need it, of course. That's in case I'm not happy with the regulation of my windmill and I want to install a dump controller. So space there for that. Well, yeah, dump controller, dump load, whatever. Well, I obviously need a controller for the load. And then I could do something else with this. I could use one of these for the dump load and one blah blah blah. So there's options there. But right now, when I first put it in the shed, I'm going to disconnect the wire that feeds from the battery bank to the solar regulator and put it in here, and then take another wire out there to the solar stuff. So getting onto it now. Oh, one last thing, we're getting quite long with this video. I've ranted about this, but you know, it's been so long since I really had a good time doing this kind of stuff, it seems. Well, I've had good times, but not doing this kind of stuff, you know. The original bolts that came with it, have I got one here? I do. Really meaty, really massive. They're probably the right size bolts for holding a terminal that's expecting 100 amps, but this shunt's never going to see 100 amps, nowhere near it. 40 amps, absolute max. 20 amps, common max, really. 10 amps, probably mean current from that windmill where it's going to be located, so total overkill. So I didn't have any massive lugs to fit on those massive bolts, so I was thinking about what to do, and in the end I decided just to put some smaller bolts on. That of course meant putting small bolts through massive holes, so what I did was I got some tin off an old spam can or stuff like Spam, something like that. In fact, let me show you. It's actually the lid off this tin here which I used on top here as a rain hood for this conduit. Yeah, it's actually the lid. So what I did was I rolled up these little inserts like this. This is one I made, but I didn't use quite enough material, so it's a bit sloppy, so I made another one. But there's one inside there and one inside there. Probably not the best electrical contact, but the main point of them is really just to hold the bolts centre so that the washers and mainly the lugs just get a nice central snug down onto this brass. So that's their main reason. They will conduct a bit, of course. There goes the meter. And while I was in the mood for inserts, this here is a 4mm banana socket, but it's a really shallow one, and the banana plugs I had that fitted into it kind of stuck out really proud and with a pin sticking out, and that kind of annoyed me. So I found this one, which is actually a narrower gauge banana type plug. And of course it wasn't going to fit in there because it was going to be too sloppy, so again I made a little sleeve, put it in there and put that in. Hey, it's sleeve day. Wow. There we go. That's day 1046 off the grid, doing off the grid stuff. Just got installers in the shed, finish off the conduit over there. I need another conduit running across to the power room so I can take the wind cables into the actual power room. And then, finally over there, that big stick will have a windmill on it, and that'll be great.